Hello everyone, in this video I'm going to discuss the example for special probability distribution. In a manufacture of glass panel, small bubble occur at a random at an average. So here we have the keyword average. So meaning that we have the hint, which is the Poisson distribution of one bubbles in every two glass panel. So in here we have the title, X is Poissonally distributed. Here we have one bubble every two glass panel. The numbers of bubble detected in a panel is denoted by X and follow a Poisson distribution. So for the question number 1, here they mention that chosen glass panel means that we only have one glass panel. So in the title above, given two glass panel, so rewrite the title where we have 0.5 for one glass panel, which means that divide by 2. Next, we must have the questions. Probability is that X greater equals to 3 because they mentions that at least 3 bubbles. So kindly refers to the tables of Poisson probability. Kindly refers to the title where we have 0.5. So here we have the 0.5. Question mentions that X must be greater and equals to 3. So here we have the 3. So if it refers to the table, so here we have 0.0144. So we can write, we already shown the situation. Kindly refers to the second question. A box contains 15 such glasses panel. So in here, they mention 15 glass panel means that n is equal to 15. Inspection are carried out at random to ensure the quality. A box is rejected if it contains at least 2 glass panel with at least 3 bubble in each. So this one will be the title because previously already mentioned 0.0144. That is the probability. So here we have the title. X is binomially distributed. We have 15 and 0.0144. That is the probability. So by refers to the question, they mentions that at least 2 glass panel. So probability is that X must be greater equals to 2. So kindly refers to the question. So here they mentions that we have n equals to 15 and p is equals to 0.0144. We have the previous experience. Notice that this kind of question cannot be solved by using the statistical table because the p is 0.0144. So what we can do is to make use of the formula where we have 1 minus probability that x equals to 0 minus probability that x is equals to 1. So kindly substitute the situation. 1 minus, we have 15C0, 0.0144 power of 0. And then we have the Q, 0.9856 to the power of 15 minus 15C1, 0.0144 power of 1, 0.9856 to the power of 14. So make use of the calculator. 1 minus 0.80447 minus 0.17630. If we sum up, we will have 0.9808. Finally, probability that x greater equals to 2 will be equals to 0.0192. So that is the probability that randomly chosen box is rejected. X is random continuous random variable with a normal distribution. So here we have x is normal with the mean mu and standard deviation squared, which is the variance. Give that, we have the question, probability that x greater than 128, which is equals to 0.15. Another one, we have the probability that x greater than 97 equals to 0.75. So kindly refers to the questions. First, what we have to do is to standardize. Greater than 128 minus mu over the standard deviation equals to 0.15. So kindly refers to the diagram. As we all know, Z is located on the right hand side and then here will be the shaded region. So the formula will be the same, Z greater than 128 minus mu over the standard deviation equals to 0.15. So kindly refers to the table and we notice that the probability 0.15 and the Z is equals to 1.0364. So 128 minus mu is equals to 1.0364 sigma. or we can state the standard deviation, and we name it as the first equation. Next, move on with the second equation. We standardize the situation. 97 minus 1, we have the mu over standard deviation equals to 0.75. If it refers to the diagram, z will be located on the left, which is the negative z. So here will be the shaded region. Rewrite the formula. So here will be the situation z. So the formula will be 1 minus probability that z greater than 97 minus mu over the standard deviation equals to 0.75. If we rewrite the situation, so the z 97 minus mu over the standard deviation is equals to 0.25. By referring to the statistical table, page 23. So we notice that the z is equals to 0.6745. That will be the answer for this part. If you refer to the diagram, the original z actually is located on the left hand side, where we have the negative sign. So now the z will be equals to 97 minus mu equals to negative 0.6745 multiplied with the standard deviation, and we name it as the second equation. So if we continue, so what we have to do is to eliminate the mu. So my suggestion would be the first equation minus the second equation. So 128 minus the 97, and we will have 31. Negative mu minus with the negative mu, and we will have 0. 1.0364 multiplied with the standard deviation. If we minus with the second equation, so we will have plus, where we have 1.7109 standard deviation. So the standard deviation will be 31 over the 1.7109, and we will have 18.12. Kindly sub the standard deviation 18.12 into the first equation. So 128 minus mu equals to 1.0364 multiplied with 18.12. So we will have mu, which is equals to 128 minus 18.78. So the mu will be equals to 109.22, and the standard deviation will be 18.12. Eggs produced by a farm are classified as large, medium, or small. So L will be the large, M will be the medium, and small will be the S, based on their weight. It is known that the weight of the egg are normally distributed. So meaning that here we have the title, 80 as the mean, and the standard deviation 10 squared because of the variance. And 8 is considered small if the mass less than 72. So here we have the question, x less than 72. It is known that the portion of the medium and the large are the same. So means that here they will have 2x. So calculate the border weight which separate the large and the medium egg, meaning that the weight. So focus on the question. First, what we have to do is to standardize. We have z less than 72 minus 80 over 10. So the p z less than, we will have the situation negative 0.8. So refers to the diagram. So here will be the negative 0.8, and here will be the region. So 0.8, and here will be the region. Rewrite the formula. So z greater than 0.8. So by refers to the statistical table, page 20, and we have the probability 0.2119. So now how many percent of 8 that we have for the small category? The answer is 21.19% of the small egg. So in order to find the large and the medium, so basically we have the simple maths. So 100% large and medium, we have 100% minus the 21.19%. So we have the answer, which is 78.81%. So if it refers to the highlight part, they said the portion of the medium and the large eggs are the same. So means that we have to divide by 2. And focus on the large medium. So we consider that the large eggs is 39.41%. Or in the probability form, 0.3941. So consider the probabilities that the x is larger than the weight given, then we consider as the large H, which is 0.3941. So first, what we have to do is to standardize. So probabilities that Z greater than L minus, we have 80 over 10, 0.3941. So if you refer to the diagram, Z will be located on the right hand side. So the answer will be the same, or we can say the formula will be the same. If you refer to the statistical table and we notice that the probability of 0.3941, the Z is equals to 0.27. So based on the calculation, 0.27 is equals to L minus 80 over 10. So we have L, which is equals to 0.27 multiplied with the 10, so we have 2.7 plus with the 80. So the weight for the L size would be 82.7 gram. So that is the border weight which separate the large and also the medium eggs. So 82.7 gram. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.